All right, our next section is on classifying polynomials and polynomial operations. Mainly, we're going to talk about adding, subtracting, and multiplying only today, no division yet. And the first part we're going to talk about is how to classify polynomials. And they're classified in two ways. Okay, we give them a name by their degree, which has to do with the largest exponent on our variable. So if I look at this one, say in example 1 here, if I look at the exponents on my variable, we have 2, 1, and technically, you can even say anything to the 0 power as our constant here. So we go by the highest degree. And if the highest degree is 2, we should hopefully know the name for that. That had to do with our whole last chapter. Those are called quadratics. So the different names they're given by the highest degree that they have. If it is degree 0, meaning there's no variable at all, like say down here in number 4, this would be called a constant. Right? It's just a constant. There's no variable with it, so it makes sense. We just call that a constant. Okay. Next, if it's the highest degree is 1, like n to the first or a to the first, say here in example 5, a to the first is our highest degree. This would be linear. Okay, and that's because those things, when we graph them, look like lines. Okay, we already said degree 2 is a quadratic. Degree 3 is called cubic. So down here, say in example 6, degree 3 is our highest degree, right, compared to 1 over there. So this would be cubic. Okay, anything that is degree 4 is quartic. Quartic, think like quarter, right? 4 quarters and dollar. So quartic, not quadtic, but quartic. So do we have a degree 4? I think we do right here. Right, it's degree 4 is our highest degree, so this would be quartic. Move that over here. Okay, and if you have anything with degree 5 as the highest degree, which it doesn't look like we have in our example, that would be called quintic, like people that have quintuplets. It's having 5 babies all at once, right? Anything that's a 6th degree or higher, and it looks like we have 1 here. 6th degree is the highest, right, compared to 5 and 1. Then we just call it by that degree, so we would call this a 6th degree polynomial. So if 8th degree is the highest, we'd call it the 8th degree polynomial or an 8th degree polynomial. So anything bigger than 6, we stop giving specific names. Okay, so let's finish some of these by degree. Number 1 here, squared is our highest degree. So this is degree 2, quadratic. Okay, our number 3 here, again, n squared means we have another quadratic. Okay, keep in mind this is only half the names of each of these. And down here, a little out of order, so we need to be careful. Here is the highest degree, right? Degree 4, which is quartic. Quartic up here, degree 4, quartic. Okay, so we also give them a second name, which is by how many terms they have. And terms, okay, are things that are separated by addition or subtraction. So if we only have 1 term, it's called a monomial. So nomial itself means terms, and mono means 1. So it's kind of blended together, monomial. That would be 1 term. So in fact, number 3, there's only 1 term here, right? So this is a quadratic monomial. Okay, same thing with down here. This is a constant monomial. Anything that has 2 terms is called a binomial. Again, nomial means terms and bi means 2, like bicycle or bilingual. So things with 2 terms, let's see, number 5 is a binomial. Number 6 would also be a binomial. Okay, and I think that's it for binomials here. If it has 3 terms, again, nomial means terms, tri means 3, so trinomial. So things with 3 terms, like number 1, has 1, 2, 3 terms. So this is a quadratic trinomial. Okay, number 4 is a 6th-degree trinomial, has 3 terms. Down here, this also has 3 terms. This is a quartic trinomial. All right, if you have 4 terms or more, so that includes 5, 6, 7, or 8, we go back to the generic poly, which just means many. You guys might remember polygons in geometry. Gons means sided, so many-sided. Anyway, polynomial just means many terms. And so here, this is polynomial. So if you have 4 or more terms, right? 1, 2, 3, 4, or more, we just go to the generic polynomial. All right, next we're going to look at our polynomial operations. So let's start with adding, probably our easiest operation. When adding polynomials, we are going to be combining like terms. So we're just going to add or subtract the numbers in front of our variables. Okay, what are like terms? They are things that have the same variable. So for instance, if I had 4a and 3b, these do not have the same variable. They would not be like terms. So not only would they have to have the same variable, like 3a and 3a, but if this one is squared and this one is to the first power, they are still not like terms. They also have to have matching degrees on all variables. So if this is squared and this is a to the first, these are not like terms. We cannot add them together. Okay, so it has to be the same variable and the same exponent. And if that's true, they're like terms, and then we just add the number in front, which is how many of those we have. Okay, so let's take a look at a few examples here. It says perform each indicated operation, then classify or answer by degree and number of terms. Okay, and here these parentheses are really just to tell us this is one polynomial and that we are adding a second polynomial. Be careful, just don't assume when you see parentheses that we're multiplying here. We are given an operation, right, which is just to add. We're just adding these together. And because we want to put our highest degree term first, this is called standard form, where you put the highest exponent first. Let's go to combine those like terms first. And I see the highest degree we have is 4, and we do have 2 terms that we can add together. Negative 1x to the 4th plus positive 3x to the 4th. So negative 1 and positive 3 make positive 2x to the 4th. Remember, we're just adding the numbers in front there. We had 1 negative and 3 positives. Okay, next up, we'd see if there were any x to the 3rd terms. That would be the next exponent down, right, from our highest. There aren't any. There are some x squareds, though, so let's go to combine those. 7x squared and 2x squared, when I add them together, gives me 9x squareds. We don't have any x to the firsts or any constants. That's what we'd be looking for next, but this is our answer. So now we're going to name by degree. Remember, the highest degree here is 4. If you look back on our list, degree 4 corresponded to quartic. So we'd call this quartic. And then we would name it by the number of terms. And we have 2 terms. So if we look back, 2 terms meant binomial. So this is a quartic binomial. Okay, for number 10. Again, we're going to add these together. So we're not multiplying, we're just adding. So we're looking to combine like terms. We look for the highest degree term. And I see we have n squared, looks like the highest. So let's combine our n squareds. 5n squared and 2n squared makes 7n squared. Then I would look for n to the first, and I see we have 1, 2, n to the first terms. Positive 4 and negative 6 gives us negative 2 n to the first powers. And then we would look for any constants at the end. So positive 3 and negative 1 added together give us positive 2. So again, if we're naming this by degree and number of terms, by degree, this is a quadratic, right? It's degree 2. Quadratic. You can look back at that chart. And then by number of terms, there are 3 terms, 1, 2, 3, which means it's a trinomial. Okay, next up, let's talk about subtracting polynomials. When you're subtracting, it's important to know that's the same as adding the opposite. And so we'll see that through our examples here. So we're going to add the opposite. We're basically going to turn it into an addition problem and then combine like terms, just like we did in 9 and 10. Okay, so here's a couple examples where we're asked to, this time, subtract polynomials in this order. So here's what I mean when I say we're adding the opposite. We're literally going to change this into an addition sign. So we're going to add, and then we're going to make each of these the opposite sign. So instead of positive 4r squared, we're going to have negative 4r squared. And instead of negative 3, we're going to make that positive 3. So we're going to add the opposite. And now we're going to combine like terms with what we have over here, 6 plus 4r to the 4th. So we're just looking for like terms to combine. And it looks like our highest degree term is r to the 4th. And we have positive 4 of those, 4r to the 4th. No other r to the 4th to combine with. There is no r to the 3rd, so next we would do r squared. And there's only one negative 4r squared, no other r squareds. There's no r's to the 1st. And so lastly, we combine our constants. 6 and positive 3 make 9. So once again, we were asked to name these by degree and number of terms. This would be a quartic, because it is degree 4. Quartic, like 4 quarters. And it has 3 terms, 1, 2, 3, trinomial. Okay, our next one, number 12. Again, we're subtracting. And to subtract, we're going to change this to adding the opposites. So this becomes positive 2 plus 2x minus 2x squared. So we change all of the signs in the second set of parentheses. And it's now essentially just a big addition problem where we're just looking to combine like terms like we did above. So it looks quick scan through. I see x squared is the highest degree term. And we do have 2 of them. Positive 5 and negative 2 give us positive 3x squareds. Next, I see x to the 1st. We do have a couple terms. Positive 8 and positive 2 give us positive 10x. And combining our constants, 4 and 2, both positive, give us 6. So here is our results, and we subtract those in that order and naming them by degree and number of terms. This is a quadratic, because it's x squared, quadratic trinomial. Okay, last note here on adding or subtracting. Note when you add or subtract polynomials, exponents on our variables do not change. Remember, we're combining like terms, and they have to match to be like terms. We're only adding or subtracting the numbers in front of the variables. Okay. However, in our next slide, when we talk about multiplying and dividing, exponents can change. So exponents can change here when we multiply, right? Think about, just x times x by itself means x squared, right? So when we're multiplying things with variables, our variables can increase or decrease. Okay, so let's find our product here. So we multiply 4x times 7x. We're going to do the 4 times 7, which is 28, and x times x, which is x squared. Then we're going to distribute our 4x to 8. 4 times 8 is 32, and then times just the 1x, right? That's coming over with our 4. So 4x times 8 is 32x. And if we were classifying this by degree and number of terms, this would be a quadratic, because x squared is the highest degree. Binomial, quadratic, binomial, because there's only 2 terms, and we name it by number of terms. Remember, 2 is binomial is terms. Okay, for 14, very similar. If we were to distribute this 2m squared here and multiply through, 2 times 3 is 6. M squared, so if you're thinking about what's happening here, m squared times m, remember this means m squared means that, and then we're multiplying by another m. So this is really m to the 3rd, right? Or you can even think of our property from exponents that we could add the exponents here. But this becomes 6m to the 3rd. 2m squared times negative 5 gives us negative 10m squared. Okay, and if we were naming this by degree and number of terms, this would be a cubic, because So degree 3 is our highest degree, so that's called cubic. And 2 terms is binomial. Okay, so this next example in 15, you've definitely seen ones like this before. Like these would be things like we factored our quadratics into. And so if we multiply them back together, I think we'll end up with a quadratic this time. So let's start with our 1m, and our goal here is to make sure that each term in the first set of parentheses gets multiplied by every term in the second set of parentheses. So we're just going to start with m and distribute our 1m. Okay, I'll even put a 1 here just to remember that it's really 1m. So 1 times 3 is 3, m times m squared. 1m times 6 makes 6m. Okay, so we distributed our 1m to everything in the second set of parentheses. We're done with it. Now we're going to come back for the positive 2 and distribute it. 2 times 3m gives us positive 6m, and 2 times 6 gives us 12. Lastly, we're going to look to combine like terms here. I only see one term with m squared, so we'll just drop that down, our 3m squared. We do have 2 terms with m to the first, and together those give us 12 m's. So now we're adding or subtracting, right? Combining like terms like we did on the last slide. And then we have just our lone constant of 12. Okay, so we can leave our answer like this, and if we're naming it by degree and number of terms, this is a quadratic trinomial. All right, number 16. We're taking a binomial times a trinomial. So if you learned the word FOIL to do problems like 15 before, it no longer applies to 16 because there's too many steps to spell FOIL. Okay, but if you understood the idea of what I just talked about in 15, then 16 is the same thing. We're going to start with 7k, and we're going to distribute it to all 3 terms in the second set of parentheses. So this will take a little bit longer. 7k times 8k squared. 7 times 8 is 56, and k times k squared makes k to the third. 7k times negative 7k. 7 times negative 7 is negative 49, and k times k makes k squared. 7k times negative 3. 7 times negative 3 is negative 21, and then we're just bringing the 1k over with our 7. Okay, so we've distributed 7k to everything. Now we're going to distribute our positive 3. Okay, and I know I'm going to run out of room trying to write these next 3 terms. Probably. We'll see if we can squeeze them in. Positive 3 times 8k squared will make 24k squared. 3 times negative 7k makes negative 21k. And 3 times negative 3 is negative 9. Just barely enough space there. Okay, but we have tons of terms that we need to simplify. We have some like terms to combine. So again, we'll write it in our standard form where we start from the highest degree down. So we're going to write k cubed, or k to the third. 56k to the third would be our first term. No one to combine them with. We do have 2 with k squared. Negative 49 and positive 24 make negative 25k squareds. As far as k to the first, I see 2 terms that have k to the first. Negative 21 and another negative 21, which makes negative 42k to the firsts. And lastly, our constant at the end here, negative 9, no one to combine him with. So if we're naming this one by degree, it's degree 3, so that's cubic. But we have 1, 2, 3, 4 terms. Now remember, if we got above 3, above trinomial, we went to the generic polynomial. Anything with more than 3 terms, we just call it many terms, polynomial. That's it. See you in class.